Good morning, fellow mathematicians! Welcome back to another video. Linear functions yet again, and if you want to learn more about linear functions, link to the playlist down there in the description as well as up here in the info box. We are nearly done with the linear function playlist, and there are only 2 episodes left now here on this playlist. Namely, we are going to do practice sessions yet again, just like we always do here on this channel. And we are going to start off with the first practice session today. And here are the exercises. Make sure to try them out for yourself at first. Okay, it's just one big exercise under one big title with a lot of sub-exercises. And once you're done with finishing the exercises, keep watching the video now for the solutions. And we are going to dive right in. So, here's the main theme for our exercise. Imagine you are going to get yourself internet, okay, an internet contract, and it comes with the following conditions. Namely, you are going to have a monthly fee that you need to pay each and every month, and it comes as a price at a price of $20, okay? $20 is the monthly fee. But that's not the only thing. To get yourself the internet at home, you also need a router. This is something that you need. And to get yourself the router, you must pay a one-time fee right at the beginning, at the start of signing the contract. And the fee is going to be, for the router, $52. Okay, this is how you are going to get yourself the prices together. And now for the first exercise. The first exercise is going to tell you that we need to calculate the total cost that you need to pay, basically, during the first year of the internet service. Okay, let us go through the thought process here step by step. So, on the one hand, you need to pay each and every month a certain fee, which is the fee of $20, meaning you have to pay for 1 year $20 each and every month, meaning, okay, there are 12 months in 1 year, meaning overall in this first year you are going to pay 12 times $20, okay, don't forget your units. Okay, 12 times $20, but it's not the only thing. You also need to pay for the router in the 0th month, basically, of you possessing the new internet, meaning we need to also add the $52 to the whole thing. Now we can calculate everything. So 12 times 20 is 240, okay? $240 plus, okay, plus $52. And overall this is going to result in $292 overall in the first year of service. Yeah, and hence we are done with the first exercise. That was easy, right? Now we want to get ourselves the functions equation of a linear function which satisfies this given real-world application, you could say. Okay, at first we are going to draw a graph because this is going to make our life a tiny little bit easier. If we were to draw a graph, okay, let's put it here. Then we have to think about the axis. What does lie where? So the thing is, the price you have to pay is dependent on the time you actually take the service in. Okay, so meaning the longer you have the internet contract going, the more money you need to pay. Meaning the money we need to pay is dependent, not euros, it's dollars, is dependent on the time you actually use the internet. Meaning down here we got the months. So months are the independent variable here, and our euros or dollars whatsoever are the dependent variable. They depend on the duration of you using the actual internet. Okay, now let's just imagine we are at the first month of service, okay? At the first month, how much did we pay up until the first month of using the service? Okay, overall we are going to pay $20 because we used it for 1 month, but also we paid for the router in the beginning, meaning 20 plus 52 is going to give us 72, meaning we are going to have an intersection point at 1 and 72 up here. Okay, this right here is the first point that we are going to hit with our graph. But we also need a second point. The second point is something that you can find out pretty intuitively. What happens if you just now signed the contract? You haven't used the internet yet. You didn't use the internet at all up until this point. But once you sign the contract, you need to pay for the router immediately, because this is like the base cost you need to pay, because otherwise you wouldn't have internet at home. Meaning, at the 0th month, we actually had to pay $52 to get the whole thing going. This lies directly on the y-axis, meaning 52 is actually our y-intercept, which is going to be important in a second. Now we can connect points, And hence, this right here is our function being graphed into a coordinate system. Now, we are going to turn this graph into, well, just a functions equation. So we know in general a linear function looks as follows. We have ax plus b, where a is our slope and b is our y-intercept, okay? The y-intercept, like I said before, is at 52. This is good, meaning we're going to have a function of the form ax plus 52. Now what about a? We can kind of intuitively really easily find it out, but we can also calculate it. For this we only need one more point that we are going to plug into our f, and then we basically can solve for our a. There are a few points already given that we can use. For example, we can make use of this very point that we have up here. If we were using the service for 12 months, we are going to pay $292 for the service. Meaning what we can do, we can plug the 12 months into our x, because the x values correspond with the months, okay, using the service. So f of 12 is going to result in $292. Well, and now we just need to plug the 12 into each and every x up here, meaning we're going to make use of this equation here to get a times 12 plus 52. And now this right here is our equation, and we are going to solve for a naturally. For this, we are going to bring everything that's a on the one side and everything that's not a on the other side. At first, let's get rid of the 52 that we are having here, meaning we are going to subtract 52 on both sides, leaving us overall with 292 minus 52 is going to result in 240, being equal to 12 times a. And now we are going to solve for a by getting rid of the 12 here, meaning we are going to divide both sides by 12 overall, with 12 cancelling out on this side, leaving us with a value of a being equal to 240 divided by 12. Well, this is just 20. Meaning our a is 20, meaning the functions equation that describes our real world problem, whatever, is going to be 20x plus 52. Which does make sense, because we are going to have a base cost of $52 for the router, and then each and every month we are going to pay a steady rate of $20, which does make perfect sense. Our slope is bound to be $20 because we are going to increase our function or the points in the function by $20 each and every month. Does make perfect sense if you think about it. Another way to actually find out the functions equation at a glance is by using what we have up here. If you take a look, we are going to have the equation months times 20, months times 20 plus 52. This right here is corresponding directly to just making use of our functions equation by plugging in certain values, 12 and 292 overall. Yeah, and that's basically it. This already concludes this exercise. Now, next exercise wants us to draw the graph of this thing, and gladly, we are already done with that. Take a piece of paper, okay, and try it out for yourself really nicely. Use your ruler and pen and everything and your pencil, and then it's going to look nice. So we are done with that exercise. Now we are going to go for the next one. Now those next exercises are not really with respect to the real world application here. They are just basic exercises that you kind of need to do sometimes when dealing with linear functions. We now gotta find out the zero or the root of this function, meaning what is the x value where our graph cuts through the x-axis. Okay, let us take a look at our graph. Intuitively speaking, it's going to be a negative value, because if we take a look at our graph, it hits the x-axis at negative something. So that's already a nice hint. We gotta have a negative value. Now, what about the x-intercept, you could say, the root? What is going to happen to our y value? Let us recap this a tiny little bit. Our y value is going to get smaller and smaller up until, oh, we actually hit y being equal to 0. This is where our x value is going to be located, at y being equal to 0. Meaning, if we just interpret this as basically evaluating our function at y being equal to 0, we are going to get that 0 is hence nothing but 20x plus 52. And now we are going to solve for x right here, which is going to be rather easy. We are going to subtract our 52 at first on both sides. We are going to get that 20x is hence nothing but negative 52. Now we are going to divide both sides by 20, because it's not equal to 0. And hence we are done. Our root x naught is nothing but negative 52 over 20. Okay. This can be reduced quite a bit, simplified, this fraction right here, because those are both even numbers, so they are divisible by 2, but they are also divisible by 4, both of them. I mean, 20 divided by 4 is going to be 5, and 52 divided by 4, okay, this is 40, that makes 10, 12 is the rest, okay, 12 by 4 is going to give us 3. So overall, our 0 is going to be at negative 13 over 5. And hence we are done. That was easy, right? Next up is the exercise. We need to find out the area which is bounded between our graph, our x and the y-axis. Meaning if we were to draw our triangle in that we are going to get out, it's just this little piece where we need to find the area of. Let us draw this out a tiny little bit. So if we take a look at this triangle, it's going to look as following. We are going to have a right triangle, and this right triangle is going to start right here in 0, 0 at the origin of our coordinate system. Now, in order for us to find the area of this triangle, we are going to get ourselves the sides A and B, and the total area is going to be A times B by 2. Now we need to find out A and B. What are they exactly? And I'm going to give you a tiny little hint here. You know, our function is going to cut through the axis exactly at those points. Now, those are the y-intercepts and the root, exactly. This is really nice, so I kind of prepared you guys for this exercise beforehand. Meaning, we are just going to take a look, when does our function cut through the y-axis, exactly at y being equal to 52, meaning this spot up here is at 52, and when does it cut through the x-axis? Well, at exactly negative 13 over 5. Okay, now we just need to find out the distances, which are represented by A and B, and then we are going to plug it into here, and then we are done. So what is the distance between 0 and 52? Well, obviously 52. And what is the distance between 0 and negative 13 over 5? Well, that's just 13 over 5. And now you can compute this right here, and then you are done. If I'm not mistaken, I mean you can cancel out the 2's right here on the 52 and the 2, giving you 26 times 13 over 5. And I think this is going to result in 338 over 5. Okay, overall, just as a little estimation, this is 47 dot something, 47.5 if I remember correctly. I can't remember. No, it's 67.6. This right here should be the solution to this problem. I have done it in the German version before. Now we are going to go ahead and take a look at the next exercise. Namely, we are going to reflect our function at the y-axis, and at first we want to find out what the function's equation is, and after that we want to kind of argue which real-life situation this new graph could correspond to, or this new function. So at first we are going to remember how we actually reflected functions at the y or the x-axis. Imagine you're going to put a mirror exactly on the y-axis. Now you're going to look into the mirror, and what are you going to see? I mean, your function runs exactly into the y-axis, meaning one point our new function is going to go through is the y-axis, so the y-intercept. But also each and every point that we had here, for example at 1, is going to be reflected to the same y coordinate, but with the negative sign in front of the x points at the x coordinates. Meaning at -1 we go through 72 yet again, connect the points, and then you are done already again. So this is how this works. Meaning, what about, and this right here is our function f star, that's just a reflection. Now what about the function's equation for this reflection that we're having here? Sorry, my throat is still hurting. Now, our f star of x. You might notice that the y-intercept is still the same, meaning it's going to look as follows. We have something plus 52 again. Also we are going to have an x, it's a linear equation, linear function. But what other thing can we identify here? You might notice something, namely our slope or the rate of change basically is going to stay the same. It goes up with 20, but this right here falls with the same rate, 20, yet again. Meaning our slopes are basically the same, just with difference that our function is not increasing anymore, it's decreasing, meaning we're going to have a negative sign in front of the original slope, negative 20. And hence we are done. This right here is the function's equation for the reflected function. Now, in which real-world application could you find a function like this? Well, just imagine it like that. Let's say you owe someone $100. This right here is our dollar axis, meaning $100 is somewhere here. You owe someone $100 and you want to pay them back one after another. You want to pay them back at a rate of $20 per month. And at some point you are going to be done paying them back. Instead of paying some kind of company to use their internet services, you could interpret this graph as paying someone back over time. Okay, this is like a graph or like a situation where your function could be applied to possibly. Okay, now that we are done with that, we are going to take a look at the very last exercise, namely there's this guy Andrew Dodson. No one knows about him. He's really he's really not ubiquitous here on the STEM YouTube. Andrew got himself an internet contract as well, but he got a different one. Namely, he's going to pay $15 per month for his internet, but in before he has to pay $75 for his router. Okay, so there's a difference. We are paying $20 per month for our internet contract. He's only paying $15, but the base cost is higher for him. And now we want to find out, so you could get yourself different types of exercises being kind of renamed a tiny little bit. You could either ask yourself the question, when does Andrew pay less for his internet contract at which point in time? Or starting at which month do both pay the same amount, okay, for their internet contracts? Those are two exercises that you could possibly get yourself into, and both actually go for the same procedure that you need to go through. We need to find their intersection point of those two graphs. Also, we are going to graph them later. So at first, we are going to put them into a coordinate system, both of them, and we are going to compare them a tiny little bit. So let us take a look. So if we take a look at our original one, we are going to go through 52 here. And in the first month, it's going to be at 72. This right here was our original problem. Now for Andrew, it is the case that he's going to have a base cost of 75. So it's going to pass through here. But overall, he's only going to pay $15 per month. Okay, meaning the slope is not as high, meaning it's not going to rise as much as our function before. So if you interpret this, they are going to meet at some point. Meaning, for example, Andrew's function could look something like this. We don't know this yet. And they are going to hit each other in some point. They are going to intersect. Now we are going to find out what the function's equation for Andrew is. And for this, we are just going to take a look at our original function. Think back, 52, our y-intercept was the base cost, and 20 was the rate at which our function was rising, meaning the monthly fee. Meaning the function that is going to describe the internet contract of Andrew is going to be 15 times x plus 75. And that's basically it. This right here is the function that is going to dictate how Andrew's internet prices are going to go up over time. And now we are going to look for the intersection point of the two functions f and g. Now the intersection point, we have done this before, is just going to be the point where they say where they share the same x and y points, okay, x and y coordinates. Meaning, if we just say both correspond to the same y coordinate, we are going to say, well, both of those are y, then both of those are also equal at this point with the same x coordinate. So what we can do is we can say, okay, f is going to be equal to g. 15x plus 75 is going to be equal to 20x plus 52. And now we are going to solve for our x coordinate. For this, we are going to subtract, for example, 15x on both sides, because we are going to bring everything that's x to the one side and everything that's not x to the other side. And also we are going to subtract 52 on both sides. So minus 52, leaving us overall with, okay, 20x minus 15x is going to give us 5x, is equal to 75 minus 52 is going to give us 23. And now we are going to divide both sides by our 5 that we're having here to isolate our x, meaning our x, our month of intersection, you could say, where they both have paid the same price overall, is going to be at 23 over 5, meaning this right here, okay, 5 fits 4 times into 20. and 5 fits 6 times into 30, meaning at 4.6 months they are going to pay the same amount, or they have paid overall the same amount for their internet contracts, you could say. Now, if the question is asking from you to find out the month at which it starts that Andrew is going to pay less than the first person, you have to think a tiny little bit, because you can't really pay inside of the month. You can only pay at the start of a month or at the end of a month. Meaning, at 4 months, Andrew is still paying more than the first person. But starting at the 5th month, this is the solution, Andrew is going to start paying less for the internet contract than the first person does. And this basically concludes the video. I'm terribly sorry if the if the explanation wasn't good or something. At some point, kind of hard to do those Sachaufgaben, those applied problems in English for me. Haven't done those in ages, and it's kind of hard to do physics problems as well in English for me, and also my throat still hurts. But other than that, I thank you guys for watching. If you did still enjoy this video, then please like, subscribe, make a comment, channel like. Don't forget to take a look at the main channel too, and to check out STEM merch. We got some very nice merch going on over there. And up until the next video, I wish you guys a flamboyant day. Ciao!